We're going to start talking about inverse functions. Why do you think we're doing that? What's the learning girl say? Can we read, or is that beyond our Year 12 brains? What does it say, Blake?
Answer your question, it says you can't do it in the use of logarithmic functions.
Okay, very good. And what's a logarithmic function? Opposite. What's another word for opposite that we use in mathematics? Inverse. Okay, inverse to exponential. Now we're pretty handy with exponential functions. We tend to be pretty on the ball with that. So we're going to introduce logarithmic functions as inverses to exponentials. Some cool words there. You can drop at a party. I'm sure that it'll impress people. Okay. So the first thing I've asked us to do is just to find the inverse function of y equals 4 e to the 2x. We know that it follows that shape there. To find this, we swap the y and the x, and then we rearrange to get our inverse function. So over here, hopefully this works. You can't really see, but that's okay. It's not your fault. Right, I'll just go through it. But you've got fx equals 4 e to the 2x, which equals y. Okay, so we're going to swap x and y, and then rearrange to get y by itself. Divide both sides by 4. Naturally log both sides. Divide both sides by 2. Happy with that? So we've got y equals ln x on 4 divided by 2, which is now our inverse function. So what do I want you to get out of that? How do we find an inverse function mathematically? Swap in the x and the y and then rearrange to get y by itself. So rearranging skills are really, really important there, as with most of math. But that brings us back to this board here. The black line there represents our inverse function. What do you notice about the black line and the blue line? They're opposite. What are they? What do you mean by opposite? I'm looking for words.
So, whatever's on the x-axis in blue is the y-axis, and it's black, and then that's the axis.
Yep, so you basically swap the axes. I just had a word for that. Sounded like reflected. Okay, another way you can think of it is the distance between that point and that point, and that line should be the same, shouldn't they? So if I measured the distance between the points here, they should be about the same. Why are my points not exactly the same? Because I've redrawn it and haven't done a really good job of it. Okay, you'll notice that I haven't got any values on there. That was pretty intentional. What am I trying to show you? I've shown you mathematically how to find an inverse function. What am I trying to show you? Yeah? How should they look graphically? Symmetrical around what point? Around what line? What point? Y equals x. Okay? So you should have a reflected function around the line y equals x. Happy with that? So if I asked you, what's the inverse function of a function that looks like, I'll do it in, no I won't, I'll redo it. Before I do that, can someone tell me what that means about the shape of a logarithmic function? What are some factors? So which one's our logarithmic function? The black one? So that's our logarithmic function here, right? Can you tell me some stuff about the range, the domain, the possible values? What's range talk about again? The y values. So what are the possible y values? So can this function go to infinity, upwards?
No.
It can go to negative infinity. So if I put range here, so you say it can go all the way down to negative infinity, must be greater than negative infinity. What about positive infinity? Why not? What's the limit then? Tell me what it stops at. I know what you're thinking. You're thinking it's petering off here. But it will keep going just very, very slowly up. So there's no limit to the top of the function. but you need a really big x number to get a really big y number, okay? You get my point. Lots of reallys. It does go to infinity, just very slowly. In the negative department, it goes very quickly towards negative infinity. What do we call like a line that the function can't touch but gets really close to? Asymptote. Is there any asymptotes on this?
Yes, we'll never touch the y-axis.
Won't ever touch the y-axis. So there is a horizontal asymptote down there. So what does that tell you about the domain?
It'll go from 0 to...
Including or not? Okay, so x must be greater than or equal to? Is infinity greater than 0?
Yeah.
So is it included in that set of values?
Isn't it just greater?
Oh, sorry, I don't want equal to. Very good. Very good, you passed the test. Is there another way we can represent those values? Because sometimes they'll come up looking like that, other times they may not. Have you seen this before? So for range, they might write an R. All real numbers, yes. And for domain, they might write positive R, same R. I just can't draw it twice because I teach numbers. That's just two. It's supposed to be the same looking R, but I just can't draw. What does that mean? All positive real numbers. Cool. How would that change if it was negative ln?
It would be the other way.
So would the range be affected?
No, it would be the domain.
Would the domain be affected?
Yeah, they would swap.
It would swap, but would the range and the domain be any different? The function would look like? Sorry, would go.
Yeah,
Exact same range and domain, but looks very different. Have a think about that.
yeah. Well, wouldn't like the infinity...
So if you flip that function, when we put a negative, what do? We flip it, don't we? If we flip that function, it would go up to infinity, and it would eventually go to negative infinity. So the range is the same. Is the domain different or the same?
It's same.
The same, even though the values will be very different. What about if I had ln negative x?
Well, that's not the domain.
So negative x, what would that mean? Would the range change? The range would still be the same. What about the domain?
That would be
As
as long as x is less than 0.
long as x is less than 0, very good. Why is that?
Negative.
How do you get a positive number when you've got negative x?
2 negatives.
Negative times something gives a positive number.
2 negatives.
Times a negative value, doesn't it? We need our logarithms to always have positive values inside. So what do I want you to get out of that? What do you think? When I started doing this 10-minute thing, what do you think I was hoping for you to get? Start at the start with inverse functions. What did I first show you?
You need to change the x and...
Yep, so how do I do that? Swappings, okay. How do that mathematically? Which is when you swap your x and your y. What did I show you after that? Inverse functions. Graphically, which linked into how logarithmic functions look. And now you understand, hopefully, the properties of a logarithmic function, specifically their range and their domain. What is left to teach you when I talk about this function here? Y equals a log or ln, doesn't matter, log-based something. And at a thought, what do you think those translations might be?
D makes it go up.
Yep, D makes it go vertically up, and what does C do? Just C? Oh, and B, okay. Most questions won't have a B in there. I debated whether to give you a B value or not. But I thought, if I give you a B value, you can always use it if it's there, and if it's not there, not. Cool. So the horizontal translation is negative C over B. Negative C over B. Just like the trigonometric ones. And you're looking at me like you want to do some practice. So question 2, 3.4. Let's go.